Hello everyone. In this tutorial, we'll be looking at how to write an assembly program using assembly program to find the factorial of a number using recursion. So note that we have already covered how to do this using iteration in the last tutorial. So please refer to that if you need to brush up on that. And also note that the input and output parts of this program are very similar to that of the last one. So I will not be covering it again in this. So please also refer to the previous tutorial for that as well. So let's jump right into the core logic. So again, we have the C++ code to facilitate us to write the code easy. So the only change is the way in which we compute the factorial. We use recursion here. We call a function, which is a recursive function. It checks the base case where n equals 1. It returns 1 if it's the base case. Otherwise, it calls the same function with an argument n minus 1, and once this result is computed, it multiplies this with n and returns this result. So first, so let's look at the same thing in the assembly program as well. So all these parts are very similar to the previous program. Note that here I'm loading the value of v0 into a1, so that when I call up a function, this a1 value can be accessed there, because a1 is one of the registers where we can pass arguments in MIPS IC. So in the core logic for this program, I am calling this compute factorial. So let's go to that section. So let's study this section and compare it with the factorial function in the C++ code. I'm telling you right away that this particular code is buggy. Feel free to think about it after I explain this part, and I'll be revealing what the error is and how to correct it at the end of this after the explanation, right? So let's start with this. Initially what it does is we are handling the base case here. So we're checking if the value of a1 is 1. So initially the value is equal to n. We are checking if n equals 1, and if it's true, then we should return 1. So in order to do this, we call jump to this particular point. We perform a conditional jump, conditional branching in fact, where we go to this section where we execute this. So we are storing the result in v1. So we store 1 factorial value, which is 1, inside v1, and we jump back to wherever it was called. Note that this jump does not go back to this particular factorial done, because recall that BEQ instruction does not modify the value of the return address. So in fact, this RA corresponds to the previous JAL that was executed. And if this particular thing is not true, then it reduces this value. So a1 becomes n minus 1, and it again calls compute factorial. So this is very similar to performing this, so where it reduces the value of n and it calls factorial on it again. So now a1 has become n minus 1, again compute factorial is called. So again this will get executed, this continues, and once this execution is done, what we are doing is we are taking this result in v1 and we are taking the value of n, we are taking the value of a1 that we had originally passed in, and we are multiplying it together and putting it back into the result. So this is performing this particular action, this particular line in C++. So that is being performed in this line number 34. Once this is done, we are again returning back to wherever it was called, so which corresponds to this particular section. After this, we are just printing the output. Now note that there is a bug right away in this when I was explaining it, because if you observe carefully, we are using a1 here. We have already subtracted 1 from a1, so the value of a1 has become n minus 1. And when we are multiplying, when you are using that value of a1 in this particular instruction, the value of a1 is n minus 1 and not n. It's actually less than n. It's not exactly n minus 1. It's not equal to n. So this computation is not correct, and hence this function is not right. Why does this problem not occur in this particular function? Because every time every time the function is called in C++, it creates an this value is copied to the function. So it's called by value, and hence the value of n is not affected. So how do we handle this? So in order to do this, we use the stack. So what we do is we store the values in the stack initially. So we use these three. So we first reduce the stack pointer by 8, which means we are allocating space for 2 integers. Then we store the return address and the value of a1. So now the value of a1, which is n, is stored in the stack. And then we perform this particular instructions. We again check for the base case. Now we can subtract it freely, because even though the value is modified, we can always get it back from the stack. Now once the value of the factor is computed, we again need to compute the result, right? So we need to compute factorial of n minus 1, which is given by v1 and n. But now a1 does not have the value n. So in order to get it back, we restore these two values again. In fact, we also restore the return address, and we also restore the value of n. Now after this particular instruction, again the value of a1 has become n. So now we just multiply the result with n and store it back into the result. So now the execution, the logic is right, and finally we also pop off. So we have used we have stored 2 integers by making space. Now we have to give away that space by popping off, and popping off is just done using incrementing the stack pointer. After that, we return back to the point where it's called. So eventually this will perform for n times, similar to this. After the base case, it starts returning back, and after the result is computed, this finally it returns back to this particular point where the original function was called. At this point, the factorial has been computed, and we just need to print the outputs, which is very similar to what I discussed in the last tutorial. So now let's test this program to see if it's working well, working correctly. So again, it's asking for a number. Let's enter 3. It's working well. Let's enter 9. It seems to be working. Let's enter 5 again. Yes, this also seems to be working. So this is an overview of how to write an assembly program to find the factorial using recursion. Please review this section carefully because it involves a few intricacies. So let me just give you a brief recap on this. So whenever you're writing a recursive function, the state of the variables, the value of the variables tend to change in each function call. So in order to retain the original values, you need to store it on the stack and load it back whenever required. So I'm storing it in this particular section of code, and I'm loading it back whenever I need it. So this is one of the important points that you need to keep in mind while writing a recursive function. The rest code is the logic code is really simple, which is very similar to the C++ code. So I highly encourage you to write C++ code and use it to write your assembly code. So that's it for this tutorial. Thank you.